All right, here we go. We're going to be becoming Pytorch experts by following all the tutorials and building and using the system. That's the way to do it. That's the way to become the expert. Actually using the software that we want to become an expert in. That's the task at hand. Building a Pytorch model. So we've been going through a lot of Pytorch tutorials so far. A lot of them. We are going to continue. We're not going to stop now. We're going to keep on going. Today we're going to be working on building with models. This is the easy part. This is the main entry point. We've done a whole bunch of subsequent sideline things in Pytorch over the last few weeks. The internals, the autograd, things that you wouldn't normally use with Pytorch. We've been digging deeper into those because as becoming part of an expert from a framework or a tool is using everything that it has to offer. So that's what we've been working on. This is the secondary tutorial on the Pytorch website where it walks through sort of a YouTube series. We're not watching the videos. We're just going through each of the tutorials in the text format, and we're going to read through it. So today we're going to be looking at the module and the torch parameter, which is going to be part of the module. We're going to find out. We walked through this a little bit yesterday, but we're going to start over again on this right now, so that way we have it all the way from the beginning to the end. And we're going to open up our right. So we barely got started here. We barely got started. So I'm going to delete everything, so that way we can retype it again. We're going to delete it and retype it all over again. All right. We'll be discussing some of the tools that Pytorch makes available for building deep learning networks. Except for parameter, the classes we discuss in this video are all subclasses of the module. This is, we're going to be building off of module. We're going to create a subclass of module, which makes it really nice because when we're using Torch and we're creating tensors inside this subclass, or this class right here as a subclass, it allows us to not have to do some of the extra things that you would normally have to do, such as turning gradients on, because it's automatic. It's all automatic. This is the Pytorch base class meant to encapsulate behaviors specific to Pytorch modules and their components. One important behavior of Pytorch module is registering parameters. Oh, right. Because that's what we're going to do with... How's it going there? Harimana? Wait, Harimana. How's it going? Thank you for clicking the hi button. Welcome on in. We're becoming Pytorch experts today. If a particular module subclass has learning weights, those weights are expressed as instances of the torch NN parameter. The parameter class is a subclass of a tensor. Oh, is it? I said the same thing yesterday. I keep forgetting that. Okay. Which is a special behavior when they are assigned as attributes of a module. That's right, because remember, you don't have to automatically enable the gradient on these because it knows that you're going to want them. It knows it. It knows ahead of time. This is what I was asking for a couple of days ago. I'm like, it should be on by default. It's on by default now. With the special behavior they are assigned as attributes of a module. They are added to the list of the module parameters. How's it going there, Kimberly? Welcome on in. Good to see you. Happy Wednesday. We're becoming Pytorch experts today. The module parameters. Yes. All right. These parameters may be accessed through the parameters method in the module class, which we use specifically when we are instantiating our optimizer, because it needs to know. Your videos are very good. Hey, Harmon. All right. Thank you. I appreciate it. Debnath. Good to have you here. It's great feedback. I'm watching a video from the beginning of every day for learning Python and coding. Yeah, we did that. I think it was 2 weeks, right? We did it for about 2 weeks. The basics of Python. We did the basics. You're from India? Hey, very nice. I'm over here, United States America, Seattle, Washington. Seattle, Washington. That's where I'm at in the United States. As a simple example, here is very simple module with 2 linear layers and an activation function, which we're going to type out. We're going to type out here. We'll create an instance of it and ask it to report its parameters. This is the part I'm kind of curious in, because it allows us to, obviously, you can get the parameters of each of the layers independently. You can also get all the parameters in the class itself. So let's type it out. Import torch. We're going to say class. We're going to say tiny. We'll call this tiny. And this will be a subclass of torch.nn.module. Right there. We're going to say def init self And then we're going to say super, I think. We're going to say tiny self, like this, I think, right? Dot init. I don't like this. I don't like having to do this part. I don't. This is the one part that I don't like having to do. It'd be so great if we didn't have to do that part right there. It's fine though. Super tiny self init. Yes, okay, we did that. All right, looks good. Can we run this now? So this is the parameters file. So Python parameters. Looks good. No errors. All right, no errors. Good. Let's create some layers. So we're going to create a linear layer with, it looks like 100 by 200, and another linear layer by 100 by 200. And then we're going to do, we're going to have a softmax activation. Ooh, now we're getting fancy now. And then a ReLU activation in between the two. Then you interview Shannon from the Black Dahlia Murderer. Oh, how's it going there, that dude? Welcome on in. Good to have you here. I'm not sure what you're talking about. I don't know what you're talking about. I'm from India. Good. All right. Good to have you here. I'm over here in Seattle, Washington. Okay. Oh, I saw your message. All right. The official McDonald's account. All right. I missed your message. You redacted it. I didn't get to it in time. That dude. Oh, crazy. Is it crazy? All right. Let's go. Let's do self.l1 equals torch dot, was it linear, like that? Inn. All right. Dot inn. Got to get those inn's in there. Linear. This is going to be a linear from 100 by 200 matrix. 100 by 200 matrix. There's a dude who looks like you. Really? Wait. Tell me who it is. We'll look him up. We'll see if they are looking like me. Do you think they look like me? We'll see. All right. Self dot activation equals torch dot nn dot ReLU, like this. We do it like that. Yes, we do. We sure do right there. Self dot l2 equals torch dot nn dot linear. And what this is going to be the output. This will be output class. So we're probably going to go 200, right? It's got to be 200, comma 10. So we'll have 10 output classes. What do they want here? Oh, all right. We're on the same wavelength here. Okay. And we'll go self dot the out activation. This is the output activation equals torch dot nn dot softmax. Pretty sure that right. Pretty sure that will work. All right, I'm pretty sure. We're gonna find out. Okay. So let's see if that runs without any problems. All right, we're good to go. All right, let's instantiate the class so that way we know that we're executing the initialization code. So model equals tiny. Let's make sure it works. No errors. All right, we're good to go. All right, softmax linear ReLU 10 outputs. All right, forward. So one thing that I like to do in my forward class is create a whole model that we could just do in a sequence. So that way we don't have to do this extra logic here. So we could do a nice little sequence here. I think self.seq equals torch.nn.sequential, right? Something like that. Self.l1, comma, self.activation, self.l2, and we're going to have out activation as well. Self.out activation, like that. I think this will do exactly what I want it to do. Maybe it might. All right, let's make sure we're gonna have no errors. All good to go. All right, our sequence didn't have a problem. All right, what is this? Hey, how's it going there, Jayton Henry or Henny? Jayton Henry. Hey, good to have you here. Oh, the F-Oren, welcome on back. Hey, good to have you here. We were hanging out yesterday. You were here. So we're doing Pytorch. We're becoming Pytorch experts. That's what we're doing. This is what the AI is written on. So if you heard of like something like ChatGPT, right? What are those AIs written in? This is the tech that they use to build it. It's called libtorch. Libtorch, you guys. Why do you look 20 and 60? You're someone always has to say that. I need a counter to say how many times people say that. John Marston. Yes, I'm in my 40s, so there's your answer. Sup, dude? Just scrolling through YouTube. Nice. Jayton, good to have you here. All right, talking to you about the Risk V emulator. Got me back into it. Nice. That's great to hear. That's exciting. Is this coding? It sure is. It sure is. We're learning to become Pytorch experts, which is one of the most prominent frameworks in machine learning and AI. Sent clock for 80 joules. Did you? Wait, you sent a clock for 80 joules? Did that happen? It didn't show up. So is this Python library? You got it. You got it. Mutar. Yes, a Python library. You look good for 40. Thank you. Jokes aside, John Martin, I appreciate it. Great compliment. Can you make an AI video generator like Sora? Yes, we certainly can. We certainly can. We should make a meme generator. It makes meme generations, like GIFs, things like that. How's it going there? 6QRE. Wait, Cray? How do you say your name? I've always wanted to learn. You're not that. Oh, no, don't worry about being smart. It's not a thing about being smart. Don't worry, I'm not smart either. We figured it's just all about repetition. It's all about repetition. Hey, Stephen A. Hey, Michael. Good to see you. Welcome on in. Good to have you here. What is Python? It's a prominent programming language for data science, machine learning and AI, web server backends, and many other things, really. It's for a lot of things. Wrote the Red Elf yesterday, and you're going to write a simpler two-pass assembler. You can do two-pass assembly? Wait, why does it need to be two-pass? I was doing a more complex one before. Okay. I'm curious about the two-pass part. Whatever company or software you are using to create your thumbnails is a little wonky. Oh, it's AI. it's AI. It's definitely AI. Hope you have a blessed day, dude. You're great energy. Energy is great. Oh, Jayton, thank you. Appreciate it. Yep. We just had breakfast and we're good to go. Is Python about games? Python can be. You can use Python to make games. You sure can. All about learning. That's right. This is about learning, you guys. I learned to code in Arduino Uno the other day with the LED. Nice. And a 5V input. So 5 volt like a battery. That's pretty neat. Technically eco. Yeah, that's great. Isn't it fun working with like real world like PCBs and breadboards and the Arduinos? It's a lot of great. I love it. You're designing it right now. I'll let you know when it's designed and you can see it. Okay, sounds good. F on. Yes. Just cause, yeah, man. Oh, great. That's great. You have no idea how to code. Oh, but you subscribed anyway. That dude, thank you for subscribing. Good to have you here. All right, we're going to see if this works here. Let's double check that we're running. All right, we're all good. Okay. Now let's write our forward method. We're going beyond the tutorial here a little bit. I added an extra thing in here. You can see here I added a little bit of extra thing right here. Hey, Steven, at some point, you take some time to talk about security in AI. Ooh, there's a good one. There's a good one. Hey, how's it going there? Xenon, hi. I had a UART board that shorted and got so hot the controller chip dissoldered itself. It dissoldered itself. Hey, Jersey, thank you for subscribing. Thank you for subscribing. You joined the right channel for software engineering. The end is nigh and uh-oh, dog. Uh-oh. The scary world. Scary world, you guys. Mark Lemon, hey, good to see you. Thank you for clicking the hi button. Good to have you here. Sir, I finally trained my own GPT with 35 million parameters, all from scratch. It takes me 2 days. Thanks to you, sir. You're my inspiration. Whoa, no way, really? That's great. Running gaming. Whoa. Good job. All from scratch. That's great. I'm who I am. You are who you are. I love you, brother. Appreciate you. Oh, thank you. That's so great for you to be here. I appreciate it. Thank you for saying that. Calgary Blue, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. That's what we do here. Good to have you guys here. Chaotic Crafter fun. It is. It's great. This is a lot of fun. Here's my talk. Here's your TED Talk on security and AI. It does not exist. Yeah, there you go. There's no such thing as security. It doesn't exist. We just pretend it does. Thank you for attending my TED Talk. It's true. It's so true. How's it going there, Lila? Good to have you here. Thank you for saying hi. Thank you for clicking the hi button. What is your favorite programming language? Right now, Rust. Rust is my favorite programming language because it's both powerful, fast, safe programming language. They have everything all in one. It's great. I love Rust. Right now, though, we're using Python. It's prominent for AI. That's what. So I like Python. I also like JavaScript a lot because that was a programming language I used a lot in the early days. I've learned, ironically though, Arduino Uno has automotive applications. Yeah, it sure does, doesn't it? Yikes, I know. How's it going there, Nox? Good to see you. Thanks for clicking the hi button. All right, you guys, let's get back to our tutorial. So we're going to write our own forward method. We're going to make it a little different here. Def forward, self, and then we're going to have our input. All right. We're going to say self.seq input. We're going to return that. Done. Easy. Easy. Isn't that much better? It's a little bit faster, you guys. A little bit faster. Trading one of one Cerebus user. Looking for base, dragon, or hydra. What? Whitney? Whitney Hunt? What are you doing over there, Whitney Hunt? What are you talking about? Bro, you stole the bottom half of the Murphy's. Oh, Cillian Murphy. Oh, yes, I know what you're talking about. I know Cillian Murphy. I know what you're talking about. The problem with Rust is most serious projects have an unsafe. Oh, I know. They have an unsafe. What you can do, though, in your project, because what we do is we forbid unsafe. We forbid it. It'll break CI. CI will say, nope, you put a safe in there. You can't do it. What is the project? How's it going there, Personality Haver? Personality Haver, we are learning Pytorch. We're becoming Pytorch experts. Hey, William Ryan, thanks for subscribing. Welcome on in. Good to have you here. Happy Wednesday. We're becoming Pytorch experts. Hey, Tasty Food, good to see ya. What are we watching? What are we doing? We are becoming Pytorch experts. All right. So right now we're going through all the Pytorch tutorials on Pytorch. We've done a lot so far. We've done a lot. Thanks for the reactions, you guys. We are going to continue onward, and we're going to use the parameters method here, which we don't. Oh, 4 parameters. Let's check this out. All right, let's try this. Okay. Let's print some things out. So we've got our tiny model. Do print model. Let's see what it shows us. It's going to show us all of our layers. It's going to show us all, and it's also going to show us the sequential. I think we could do this. I think that'll work. I think that might work. It does. Look at that right there. Right there, you guys. Certainly does. Can you run the code to show? Yep, there you go. Oh, we just did it. We ran it. There you go. Colts fan. There you go. What are we doing today? Krishna, we are becoming Pytorch experts. We're going through the Pytorch tutorial. We're going to see everything that we need to become a Pytorch expert. And right now we're working on the model, and we're going to look at the parameters. So we're going to see what the parameters are. Let's take a look. Let's print this out. All right, so print model, and then L1, because we named it L1. We changed the name. Yo, how's it going there? Yo, Golden, Elon Musk. Yeah, Henry Roberts. Thank you for subscribing. Welcome on in. Good to have you here. Happy Wednesday. What is Pytorch? Yo, is this pre-recorded? The captions in real time. I know they're good captions, right? That's some software I wrote. I wrote some software 8 years ago, and it's for free. 8 years ago, right there, you guys. 8 years ago. Right there. 8 years ago. Yep, it's free right there. Pytorch is a machine learning AI library that is used as a most popular library in AI, right? So you've heard of ChatGPT, right? There you go. You probably use ChatGPT, then you've used Pytorch. It's the underlying library that is for machine learning. Any recommendations you recommend? Yes, I recommend do Rust by example. Rust by example. Type that in, and this is going to give you a nice introduction there. Also, if you click on videos, hey, I wonder who that is right there. Look at who that is, Rust by example. Right there. So yeah, so you can get through all of the tutorials here. Go Rust by example on the official Rustling.org website. And also right there, I wonder who that is. I know. Cool, you're a smart person. We just work really hard. All right. So you can do this too. So the idea is there's sort of like 3 kinds of people on the world, right? You can be a genius at birth. You've got a special capability, maybe. Or you can be a genius of hard work. Or you could do none of those things, right? I choose genius of hard work. Let's be geniuses of hard work. Hashtag yes, Rust hate. Oh, wait, Rust is great. I love Rust. I was considering doing Rust by example on live. Nice, you should do it. It's funny that you mention it. Yeah, it's a perfect thing for living. Oh, hey, look. Wow, we're all over here. We're at the top 3 results on Google. That's crazy. Who would have thought about that? Okay, let's go on to the next phase here. Let's print this out. Okay. You're a cool dude. That dude? Hey, you're a cool dude. You're a cool dude. I'm proud of you, my friend. Hey, thank you, Christopher. Appreciate it. Great compliments, you guys. You're making me feel good. Did you have any hand in getting that in the top result? I mean, it's on YouTube. Hey, Sid. Sid, thank you for subscribing. Appreciate it. Sid Pandy, good to have you here. Hey, Loons, welcome back. Good to have you here, Loons. The only thing I did was record videos and put them on YouTube. That's it. That's all I did. It was pretty straightforward. All right, so we've got a bias. Ooh, true bias. All right, got the bias in there too. It's been a long time. Oh, no, right? A whole day. A whole day. Do print model the L1.parameters. I want to see what's going on here. Let's see what's inside the parameters. Parameters. There we go. Let's see what we got on the inside. What's on the inside? This is cool. What are you coding? Estranged. We are coding Estranged Savant. We are coding Pytorch. We're going through the tutorials and we're becoming Pytorch experts. Happy Wednesday, Sergio. Good to have you here. What library do you use for your voice text? This is my own library that I wrote many years ago. It's free. Right here, do TV OBS subtitles, and you can, it's for free, right here. There you go. Sometimes you want to add ease of reading to your stream with traditional closed captions style text so you can show your speech on screen. Right there. That's what that is. And if you want, I've got a bunch of different examples. You can have it so it just shows one word at a time, right there. One word at a time. And here's the way to do that. Center text, single word. Center text and show a single word. This is the way to do it. Right there. That's how we have it right now. That's how we have it right now. All right. Happy Wednesday. Yeah. All right. Let's do this. Let's get back. Oh, how do you feel about vibe coding? Oh, yeah. Viet AV guy. How do you feel about vibe coding? Just made a braille for Japanese, English, and Vietnamese. Quadruple A. Hey, Wrath of Legends, thank you for saying hi. Welcome on in. Vibe coding's great. You should do it. I do it all the time. When I'm not on stream, that's what I do. That's the only way I code when I'm off stream. Where are we in the tutorials? Oh, Loons. Okay, so we're pretty far. So we did introduction, tensors, autograd. Autograd was huge. That was 1 week of streams. We're building models now. Then we'll go over to tensor board, which I think is the GUI. I've never used the GUI. Training models, and then understanding the model. Hey, Captain Tet, or Captain Teach. Captain Teach, what's up? Good to have you here. Thanks for clicking the hello button. If I do stream Rust, I will likely use your real-time text thing. Nice! Yeah, it's worth it. I like it. I like it. It's great. Thanks for saying hi, Teach. Okay, so let's look at our parameters now. Let's see what we got here. Okay, so that looks like an iterator. So we have to do 4p in parameters. We're gonna see here. Hey, SMD, thank you for subscribing. Welcome on in, you guys. Happy Wednesday. We're becoming Pytorch experts, you guys. That's what we're doing now. We are gonna go through this. So print p, right? So that is a generator, right? So it's a generator. So we should be able to see. Hey, there it is. Wait, no, wait. Hold on a second. Wait. Whoa. Wait. This is weird. I'm not expecting that. That's something weird there. Steve Nash. Wait, what do you mean by that? Hey, George, what do you mean by that? Hey, any advice? Young embedded systems, embedded software engineers. How do you feel about edge computing and embedded? All right, Knox, good question. These are really great things. All right, so edge compute just means it's wherever your edge is. Where's your edge gonna be, right? Is your edge gonna be at the device? I mean, you could go all the way straight to the device, right? You can't get more edge than that. Or is edge gonna be the router in your closet? Or is edge gonna be the switch in your ISP? Is edge gonna be in the cell tower? Or is edge just gonna be a CDN style, like where the closest data center is? You gotta define where your edge is. Where's your edge, you guys? That's part of the picture. All right, you guys. People are so ADHD these days. There are some ADHD there around there. I know, right? That may be put on the side subways. Oh, is it? Wait. All right. So, how do you feel about edge computing? I love edge computing. It makes everything faster. And embedded computing, which means that you're just probably running on one of the lower power devices, right? Microprocessor. Okay. Let's see here. Don't understand the words in English, so translated my sentence into English. In short, I have been following your code. You write? Really? If possible, and if you don't. Oh, well, I'm glad you're following it. Please explain not only with words, but also by showing the code step by step. Yes. So that's what we're doing here. So we've established, so let's walk through where we are right now. We'll do a quick little walkthrough, you guys. We'll do a quick little walkthrough. Has anyone ever told you that you look like Steve Nash? Yeah, today, yeah. Today, a little bit. Oh, Vim. Yep, you got it, Vim. Which IDE is this? It's Vim. VIM. Vim, right? So Vim right here. You can see right there, we got some Vim, you guys. You got it. You got some Vim. All right, I recently started learning with the Anthropic Academy, and you really like it. They explain AI. Anthropic has an academy? They do, really? We'll have to look into that. All right, we'll walk through some of our code here. Oh, crazy idea. Might extend your words thing to do some live translations. Yes. That would be neat. That's a good idea, actually. We should probably do that. That would be a lot of fun. We could have multiple captions on the screen at the same time. Wouldn't that be neat? That would be pretty neat. Okay. Yeah, that would be great. You go live daily? Yes, Monday through Friday. Explanation of edge computing. What is your edge? Exactly. What is your edge? Where's the edge at? Please do French first. We could do French. I think that's a pretty straightforward one to do. We just need a local LLM, and we can process that and append it to the screen. Have multiple languages all at once, you guys. That would be fantastic. Okay, so this part I'm curious about right here. I'm curious about this. So we own parameters containing. Oh wait, parameter containing. Wait, hold on. I want to hide these things real quick. I just want to see what's going on here in this print statement. Okay. There we go. The translation would be a little behind, though. It would be, yeah. It would be behind a little bit because it takes time to compute it. Are you a master JavaScript and React? I am a master in JavaScript for sure. I definitely count myself master in JavaScript. I've been using it since 2000. Before 2000? When was JavaScript came out? When did JavaScript come? Wait, before 2000. Definitely before 2000. When JavaScript released. All right, that was, yep, all right, it was before 2000. It was 1995 in December by Netscape, by Brendan Ike. Remember Brendan Ike? What are we building? We are building an AI model in the tutorial. We're becoming Pytorch experts. That's what we're doing. Master in JavaScript. Yes, I remember doing this many years ago. Teach me, master. I follow you, master. Wait. We'll do our best. We'll do our best. Right now, we're doing Pytorch. We're doing Pytorch right now. All right, I want to see this real quick. All right, so there is a surprising notion. Oh, okay, check this out. All right. That's some music. Oh, it is some OG music there. I know, right? Anasazi, you made it. Hey, you said yesterday, I saw you on Discord. You're like, oh, no, I couldn't make it to the streams. You made it today. Good to have you here. Anasazi is here, you guys. Okay, I gotta take my medicine. 1 second. I get to medicine. The timer clicked. 1 second. All right, 1 second. Gotta take the medicine. Okay. Medicine. Okay. This is morning. Okay, 1 second, you guys. All right, 1 second. Okay. All right, write it down here. Morning on the ing. Okay. That's my way to remember that I took the pill. Okay, good to go now. All right. Do you know what's going on here? All right, you guys. So while I walk through the code here, I'm going to walk through the code again on the screen. I'm going to ask you guys a question. This is like a test for you. All right. There are 2 tensors printed from dot parameters. How do I want to say this? All right. What is the first one? What is the first tensor printed? This is going to be easy. The first tensor is going to be the WEIGHTS or the bias. Weight or bias. All right. I just started a poll for you guys. I just started a poll. Okay. Subscribe. Need someone like this? with whom I can code and also chat. Hey, Craig, or Crab God. All right, that sounds good. That sounds good to me. All right, you guys. So on the screen, just to let you know, we've got two tensors. The first tensor is a smaller tensor. The second tensor is pretty big, right? So we got a lot of tensors there. Hey, Loons, thanks for saying hi over there on the purple. So we got our one is the parameters. The other is which ones? So one is the bias and one is the parameters. So you can see the top one here is smaller, and the bottom one quite big, right? It's quite big right here. Look, see how big that is. That's big, and the other one is small. So which one is the first one? All right, that's what I'm asking you guys right now. Which one's the first one? Anthony King, how's it going over there? Welcome on in. Good to have you here. Is this coding? Yes, it sure is. We're becoming Pytorch experts, which means we're going to know how to do AI. We're doing AI, you guys. We're going to use AI on you. All right. So import torch is the main library to start building your AI model. We're going to create a subclass of the torch.inn module, which is basically the beginning entry point for all of your AI models. You want to start here. This is a good one. We're going to call it tiny because our parameter count is going to be pretty low. We're going to have a pretty low parameter count. These two lines are the worst lines, and you don't really need to know what they do. You don't need to know what they do. I'm going to tell you what they do. They're just really annoying looking. Maxing parameters is key, isn't it? We got to make sure our parameters are used to the max. We want to use every bit possible in our parameters. Those floating points, they only have so many bits assigned to the float, the level precision. You might want to use a B float because they add more precision in the float. I think. I need to remember, or I'm doing it the other way. Hey, Michael, thank you for saying hi. Good to have you here. Happy Wednesday. We're becoming Pytorch experts. All right. So these two lines right here. So def init is a double underscore method. This is called a dunder method. This is the dunder method. Let me comment this. Dunder method for initializing the subclass of module, right? Of the module. Double underscore method. These are magic methods in Python that allow you to do certain pretty special things, like operator overloads, a whole bunch of things. Hey, Torva! Hey, you made it in! Good to have you here, Torva. Welcome on in. Happy Wednesday. This next method, this next line is going to call super, which triggers the double underscore method inside of, well, it doesn't, it's going to trigger it, right? We're going to trigger it here. Super is going to access the parent class, which is this class here, right? So this tiny class right here, you see, is defined here. Tiny class there, right? Super is going to say, I want the parent class of our subclass, which is the module. We're going to pass in our current reference, and it's going to give us access to the instance of the double underscore method for the parent class. And we're going to run initialize on that. That just means that it's just going to trigger the initialization method on the class module. So basically, if we say class module, and then we've defined our own init here, right? Self, then do stuff, right? Do stuff. Then you could basically do the same thing here. And by calling super like this, and we've used this module here, it will call this method. That's all that's doing. That's all that's doing. Really simple. Really simple. Super simple. Flogo. Bro, how many time are you working PC? 24 hours? It's about 16 hours, I think. So not 24. About 16. I may need to have some more than 2 passes for the... I didn't know that you could do more than one. I didn't know you could do more than one F-Oron. I didn't know. F-Oron, I didn't know. I want to support the assembly code. That's the way to... gotta support it. She can code better than me. Man, she can... Oh, Granit? Who's that? Who's that? I was just watching a movie on Netflix about coding. Coding cryptocurrency? Did you? Anthony King? What was that? They have on Netflix? Really? They have a Web 3 on Netflix. Are you serious? Are you co-founder of PubNub Master? Yes, I am. Yes, I am. At Bon. Yes. You got it. You should add a little thing showing the current music playing, the corner of the screen. Oh, right. On the keyboard on your face cam. Oh, right. It would be very good. So this is called Heaven and Hell by Jeremy Blake. It is a free, it's completely free YouTube studio music, and that's why I'm playing it now. Because YouTube has copyright things and gotta play it nice. All right. So we can undo all that. Redo, redo, redo. Here we go. So that's what that does. This is going to create a layer, which is a matrix. It's also a tensor. It's going to be a 100 by 200 matrix, which you can see here on the screen. You can see the 100 by 200 matrix right here. This is the 100 by 200 matrix. Right there. Right there, you guys. Yes, it's called the startup. Oh, really? I need to check that out. I got to put that on my watch list. All of them do more than one. First pass is the Lexer, then parser. Got it. Okay, understood. FORN, got it. Okay. Because it's assembly, we need to know what address. Thank you for the heartsy, guys. Good to have you here. Appreciate it. Oh, gotta know what the address is before you assemble it to binary. Oh, yeah. On Asazi, you see the doc link I sent you on Discord. It's neat. Oh, we'll check it. Hey, how's it going there, Epic Bloxbo? Welcome on in, Epic Bloxbo. Let's check out the Discord link you said. You said you sent it in general? Okay. Hey, Common. Let's see there. Common wave on the Common. Where's my wave at? There it is. Is this... Oh. Game replay from JSON. Wait. Is this it? Wait. You gotta tell me. See the doc you sent on the link? Is it in the link share? Link share. Savon. This is from Efron the other day. How's it going there? Rit, welcome on in. Good to have you here. I don't know which one it is. Is it which one is it in general? Let me know. Oh, and also G2mer. Thank you, G2mer. Welcome on in. You joined the right channel for software engineering. We are walking through some things here. Okay, so the activation is just going to be sort of a non-linear. So one of the problems with matrix multiplications is you can create very big numbers very quickly, and that'll explode the gradient, which will collapse. It'll cause, basically, it prevents your model from learning. So you need to allow smoothness. You want smoothness in your matrices. It's got to be smooth. Got to be smooth. It was a private thread, yes, in general. Oh, it was a private thread? In general? Wait, you can do that? You can't do the private thread in general? That doesn't work like that, does it? Oh, Steven, did you hear about the Anthropic leak? I sure did. I read through that. That was so much fun to check that out. Looking through that, there's a lot of surprising things in there. Also, the gotcha system, I want them to release it. I want them to release the gotcha system. I think that would be fun. If we jump to a label, for example, we need to know where that label lands later in the binary earlier when we write out the jump earlier in the file. Okay, got it. So you need to, that's why you need to do multiple passes. Okay. The Tamagotchi would be nice. Yeah, I think that would be great. The Anthropic leak was hilarious. It was great. It was great. The other thing that happened yesterday was the Axios HTTP library, the supply chain attack. That was less funny. No. That wasn't as funny. It got us, though, as far as we can tell, it didn't really get much. Because it was only for 3 hours, right? For 3.5 hours. If you ran npm install, and if any of your dependencies had that version of Axios, it would have gotten on your system. As far as we can tell, we were safe. We didn't see any evidence on any of our computers. All right, this is another layer. Brother, when do you go live daily on your time zone? It is, today we're doing 7:30 to 9, and it might not always be that way. We might change it again. We're going to change it again. You love that Anthropic is more open now than open. Now they are. They're more open now because their harness, the agent, the harness itself, has been open sourced. Accidentally config map. Whoops. Oh no, whoopsie doodles. We accidentally released the code. We released it. I didn't mean to. It's because they're vibe coding now. They're vibe coding their own systems. Did you read the part where it's hard coded so that if Anthropic employee is doing stuff on a public open source, it will hide that they are using AI? I didn't see that part. Are they? Are they? Okay, so this next activation is a softmax, which is just going to scale down all the parameters between 0 and 1. So if your numbers get very large here, it's going to create a scale. So that way it shrinks all the numbers. So the numbers are still going to be relatively the same apart from each other in the matrix. It's just going to scale it down between 0 and 1. That's all that does. That's all that does. And then 10 is very important because that's the number of output classes. How many possible answers is the AI going to provide? So it says 10 answers possible. Good old open Claude. Now it sure is open. You got it. It's Crab God. It's open Claude now. I will send it over again. All right, so Anasazi, thank you. Let me know when you get it there. Yeah, it's hard-coded into the agent. It is. That's great. Oh, that's right. Wasn't it? It was in one of the prompts. I think I remember that. It was a prompt. It was like, never reveal that you've been vibe coded, right? Something like that. You've been coded by AI. You like Thomas Shelby, Master. Is it? Who's Thomas Shelby? I'm going to look this up right now. All right, she said Thomas Shelby. Oh, wait. I didn't know this. I know this actor. I didn't really. Wait. Oh, this is Cillian Murphy. Okay. All right, Cillian Murphy, right? Cillian Murphy. Got it. A little bit, maybe. I don't know. It's because we're both old, I guess, maybe. Also, the negative sentiment analysis. Oh, right, the negative sentiment analysis, right? Where it has a whole bunch of curse words, and it just tracks whether it's negative or not. A whole bunch of curse words, hard-coded, right? Bingo, never reveal in a prompt. That's exactly what it was. I just stumbled upon the stream. Hi. Hey, how's it going there, Zeus? Zeus, no offense, your face looks like Linus Torvalds, but with a younger hair. Oh, yeah, because we're both old. Yeah, we're old. We're older, guys. That's what old people look like. Okay, I can see to the bottom half. Okay, you can see it bottom half. Wait, what do you mean? I missed it. I missed the joke, sir. I missed the joke. Yeah, recently there's been an influx in cyber attacks. There's also been an attack on Windchill and Flex PLM. Okay. Yeah. Because it's easier to do that now with AI, isn't it? It's way easier. This method right here, forward, is going to be called when you activate the model. Like this. It'll be called input data here. Right there, input data. We need to create a, let's do a input equals, let's just say inputs equals torch dot tensor. Wait, how do we do this? How do we do random? I forgot how we do random because I don't. The bottom half of your face. Oh, the bottom half of my face. Okay, got it. Looks like that actor. Understood. All right, I get it now. I get it now. What are we coding? We are coding Pytorch. We're becoming Pytorch experts. We're walking through all the tutorials. Randint. Oh, thank you. Randint. I want rand float. I want rand float. So I just do torch.rand. And we'll do, let's see, it needs to be, what are the dimensions it needs to be? 100? It needs 100 inputs, okay. So we'll do 100, and I think that's right. Do we start with 100? I think maybe. We'll just do 100. We'll make it easy. Inputs like this. There we go. Like that. And we say print the output. Out equals print out. Just rand. Oh, there we go. Just rand. All right, perfect. Just rand. All right, we're doing it. Just rand now. All right. See, I'm good. See if I miss any of your chat messages, you guys. All right, Thomas Shelby, Cillian Murphy. All right. Hey, a Boogie. Hey, welcome on in, a Boogie. Thank you for subscribing. You joined the right channel for software engineering. Recently, oh, Torva. Oh, okay, you're right. Okay, got it. All right, we got Torva. All right. So this, all right, you guys. So we have a poll going right now. The answer, which one? All right. So the first one, the first tensor right here, is that bias or weights? The second tensor, is that bias or weights? So you can see the second tensor is much bigger. All right, you guys are going to get the answer to the poll. Are you ready? Let's see. The answer is, I'm ending the poll now. The first one is the bias, is the answer. The first one's the bias. Because it's smaller. Because the bias is always going to be a vector. The bias is oh wait, no, I'm wrong. I'm wrong, you guys. Look. No, you were right. You were right. Because look, it's a matrix, not a vector. The second one is the bias because it's a vector. The first one's a matrix. I missed it because the triple dots right there, the triple dots. Hey, you guys got it right. Good job. 73% of you correctly answered the question. The first one was the weights. It looks smaller. However, it was a trick question because you figured it out. Because this one is the matrix. And the tensor below it is a vector, which means it's a one-dimensional array, right? The matrix is a two-dimensional array. They're both tensors. They're both tensors. All right. So there's the answer. All right, let's print this out here. Hey, there we go. All right, we don't need this anymore, so let's type that out. All right, save this here. You got the wrong because I just listening to you and I didn't look at it. Oh, you didn't? Yeah, it led us straight. I know. I know, right? Yeah, the trick was right here is where the trick was. Because it shows you that there's a lot more parameters that it's not going to print out. And the other trick was right here. The double array, which means matrix, which means the weights. Because it's always a two-dimensional array. Always two-dimensional. And the bias is always going to be a vector. There you go, you guys. There's the answer in that. All right, so let's print our model. We should get 10 answers. We should get 10 answers, right? Why did that print so much more? Why did that print so much more? Hold on. Wait. That's it seems weird to me. Something's wrong. Maybe we do this. That better? There we go. That's what I'm looking for. All right. There we go. Right there. That's what I made it too big is what I did. I made it too big. You heard of the first shooter, and so I was like, gotta be the bias. Yep, it's gotta be the bias, right? Sent in general chat just now. Anasazi, all right, let's take a look. All right, in general. Let's take a look here. What do we got? Oh, okay. What do we got over here? Let's take a look. We've got a dock. Let's zoom in. Let's make it a smidge larger. Let's zoom in even further. Let's go 200%. Okay. Aethermind white paper, cognitive architecture system overview and involved path. Henry Barton Anasazi. This document outlines the architecture capabilities and future trajectory of the Arlo cognitive system and its successor. This is your model. This is your LLM, isn't it? You built this. I remember that. Oh, wait. Am I not supposed to show this on stream? Well, you gave it to Discord, so. You gave it to Discord. All right. Arlo is a fully operational cognitive system. 9 out of 10 on the capability scale. The score is limited primarily by hardware latency. 10-year-old machine. Functionally, it performs near the top scale across reasoning, autonomy, memory, and interface adaptability. Arlo serves as proof of concept that would the underlying architecture works in real-world conditions. What are we looking at here? Oh, this is going to be really long. All right, is there any section that we should really look at here? I was wrong. I said bias. Oh, you did? I know. I was wrong too. I was like, oh, that's definitely the bias at the top, right? Because it was bigger. I was like, oh, that's definitely bigger. So that's got to be, or that's got to be the bias right there. Right, where was that? It's around here somewhere. Yeah, exactly. Like, this one's definitely got to be the bias. And I didn't look at the signs, you guys. The signs right here. Right there and right here. Between those two. That's the thing. All right, Anasazi, is there anything interesting that we should really focus on? T5. I remember T5. This is the embedding. Are you doing T5 embedding? You didn't make your own embedding. A 128-bit merged representation of multiple model families. The BERT, which is transformer, math, and science. And then you've got multiple custom embeddings. So did you do your own custom embeddings? I'm actually kind of curious about this because that's something I want to do as well. The system evolves with the user and stores long-term memory. Oh, nice. Oh, you didn't just build the model. You built all the things around it. You did all the things around it. Real-time layout generation, virtual PC terminals, touch-based video editing. Wait. Oh, really? This interface is demonstrated in Base 44 demo. Oh, nice. Mean squared error regularization, softmax. Yep, you gotta have the softmax. Well, for training, you don't need softmax for inference, right? Wouldn't custom embedding mess up the model output? Only if you use someone else's model, yeah. Or is it just custom embedding for RAG? This is Anasazi's custom trained LLM from scratch. 35 million parameters, right? 35 million parameters, is that what you said? 35? 30 million param. It's not, it doesn't, you don't have it in here. I thought you said, wait. Well, he said he merged 3, right? Oh, right, 3, exactly. Well, if you do that, you have to keep all 3 together at the same time, right? For your inference and training, you always have to keep them together. 3 billion, 7 billion, and 14 billion parameters. Oh, got it. Okay. Yeah, that's vibe coder level release, the source code accidentally. It's a fine-tuned model. Is this a fine-tuned model, or did you create the model yourself? Is it like from scratch? You said okay. The Markovian dynamics used for probability density evolution. Okay. Yeah, from scratch. Okay, so it is from scratch. That's why you can do the multiple embeddings. Okay, that makes sense. Custom embedding. See, what I want to do is I want to make everything from scratch completely. I want to do my own embedding, which is pretty straightforward with the triple loss, right? You just need the training data, so that way you can create the meanings between words. That's impressive. It is, isn't it, Loons? It's impressive. All right, cognitive manifold, 4D tesseract shape where artifact states that routes live in addressable cells and edges. Trinary trapezoidal kernel. What? The logic core combined 3 valued states with piecewise linear weights for adaptive cognition. This is a bunch of stuff. Hey, Nike, good to see you. Welcome on back. Interesting. Artifact envelope. Base 6. Why doing... Oh, are you doing multimodal? Why base 64? What are you doing base 64 in here? Why would you do that? That's me. That's why I'm doing it. Yes, -1 is a deferrer. Okay. La 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 la. A whole bunch of things here. I don't know what you got going on over here. All right. So you've got a bunch of... This is not unusual. That's not unusual. Oh, okay, yeah. So using some latex here. Is this latex? Got some latex in there that I can't read. I know base 64 was just testing, trying everything. Okay, got it. Okay. Yeah, I was curious about that because it didn't make any sense to me. I'm like, what are you doing? Unless you're doing multimodal, your base 64 encoding it so that way it could see vision. You can do some vision stuff there. All right. Ingress, intake, daemon, decode, envelopes. I'm just kind of walking through this. Okay. Self states, super, 0, super. What are your supers? Weights? What is this? Wait, what's going on here? What's going on here? This is one cell. Tesseract router. Okay. So this is the 4 dimensions. You got 4 dimensions there. My favorite channel, best channel ever. You're the best, OG. Thank you, Nike. Appreciate it. Good to have you here. We are looking over Anasazi's. Okay. Anasazi's documentation here. Trapezoid cell weights on the axis. Lift to trinary. Return. Wait, this looks like a constant though. Why would you do that? This is weird. What's going on here? Hey, Anasazi, I'm looking at some weird stuff here. This is weird. What are you doing? Def modality? Okay. Cell adder. Cell, okay. Alright, that's fine. Yeah, the Tesseract is neat. A way of having a smooth kernel. Oh, we like the smoothness. We like the smoothness. We do. We like the smoothness. How's it going there? A YouTube edit. YouTube IT department. Oh, YouTube IT department. How's it going? Good to have you here. It's like having a -1. Okay. Welcome on in. It's like gibberish form. Yeah, there's some gibberish in here. There is. Oh, that's zero trust. Okay. Implement trapezoidal aggregator. This is odd. I'm seeing some non-human stuff here, Anasazi. I'm seeing some non-human thinking. You're looking at the computers. Skynet has a way of thinking. It does. OG King, thank you. Thank you, Nike. We like smoothness. We sure do. Alongside, we are not talking about smooth brains. Right, not the smooth brains. We like smooth matrices. That's a deep fake. The dep is fake. I know, right? Is it generated by AI? I'm seeing some AI stuff in here. We've been using AI. We know what it looks like. Okay. All right. We're basically wrapping up on this now. This section is for monospace font. It's not in monospace. Yeah, because it's all markdown. So what you guys got to do is when here. Okay. Did you guys know about this? Strap in. This is a thing that you can do. Watch this. Copy. Watch this. Okay. Paste from markdown. Are you guys ready? Paste from markdown. There you go. Now it's all formatted pretty. Do the paste from markdown in your files. Do paste from markdown, you guys. You gotta make sure to paste from markdown in your documents. Hey man, still in the Pytorch? Yes. Yes, that's about it. All right, Anasazi, thank you. Thank you, yeah. Try the paste from markdown too. Because that helps make things look prettier. Obviously, in situations. All right, you guys. Hey, Anasazi, thank you for sharing that. It was actually pretty interesting. All right, let's get back to, we got 30 minutes, you guys. We got 30 minutes. We're going to get back to, let me double check. Setup here. One moment. Okay. 1 second, you guys, 1 second. I'm going to make sure that we are on the right track. Okay. Looks good, looks good. Uh-huh. Okay. Because I've got a meeting. I've got a meeting that happens at any second now. So I got to make sure that I'm there. Good to have you guys here. That's about it. Looks nicer. All right, yeah. Want to do GPT type LLM? Yeah, that's what we're going to do that on this channel. We're going to do that. We're going to become Pytorch experts first, and we're going to use Pytorch to build our own LLM. We're going to do it. Yep, me, my AI, and I. All right, got it, Anasazi. Got it. Got it. I didn't know they had a paste from markdown, but it makes sense though. Yeah, use the Google Docs. Oh, now you use Obsidian. Got it. Obsidian. The model, you got it. Amzad, you got it, Amzad. Hey, Anasazi, could you share the link here? Yeah, it's in Discord. You can grab it over here in Discord as well. Hey, everyone. Hey, it's Sunshine. Welcome on in, Sunshine. Good to have you here. Sun is shiny. So just real quick. Also, if you got that here, copy. The @IAM crab here @IAM. There you go. There you go. Discord. Also, yep. Torva. Discord. You can join. There's a link in the Stevens link tree on the profile, which is also, if you go right here, name it. It's right here in the link tree. Right there. Boom. Right there. Zoom in. Yes, actually zoom in. Zoom in some more. Zoom in further. Okay. Link tree right here. Boom. All right. Okay, let's get back to our tutorial, you guys. Let's get back into some Pytorch. What is this? Hey, we are building Pytorch models today. That's what we're doing. We're going through it and we're answering all your questions. We're getting really close to becoming Pytorch experts. We're like intermediate to advanced, but we are not expert yet. We are not expert. We're becoming experts. Join me together. Keep going. We're going to keep on going. All right. So we just figured out the parameters. We can print the tiny model, all the parameters. We could also print, this is what I want to do. I want to do this real quick. Let's do that one real quick. Let's do that. Okay. So we are going to hide that. We don't need that anymore. We are going to do this right here. We're gonna look at this and see what this looks like. So we're gonna use the parameters method, which is a available method in the module class. We created a subclass of that called tiny. We initialized that here, and we're going to be calling the parameters, which gives us a full list of all of these. Now my question is, will the sequence be included in that? Will it? I'm not sure if it will or not. I'm not sure if it will. I don't know. If it is, I call that potentially a problem. Potentially a problem. Usually you can just say sequential. So in worst case, we can just update this and make that look better. Let's find out, you guys. Let's find out if we completely blew it up or if we didn't. Let's find out. Okay, we've got the answers. We got our answers here. So what is this last one? This last one is going to be our bias. Oh, right, our bias on the final layer. So this is the bias on the final layer because it's only 10, right? 10 elements right there. And as you can see, our output here is 10 right there. That's 10 right there. If you can see that right there. 10 right here. Right there. Okay. So that's why the bias is 10 there, because it's a vector of the same size as the second dimension. And this is there. So now I should see 1, 2, 3, 4. I believe we should see 4 parameters. Matthias back. Hey Matthias, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. Today we are building Pytorch tutorials, and we're messing around with them. We're digging in and we're learning all the pieces of it. So we're like fiddling with it. We're fiddling with it. So we learn. We should see a total of 4 different tensors. If we are on the right track, we should see 4 tensors. I really hope so. Well, because we didn't create new ones. These are still the same ones. They're just references to it. So I only want to see 4. 1 tensor, 2 tensors, and 3 tensors, 4 tensors. Good. Okay, good. So what we did here is completely valid. That works perfectly fine. We're going beyond the tutorial. We're learning together, you guys. Hey, how's it going there? iFabug. Welcome on in, iFabug. Thank you for the hearts, you guys. Appreciate it. Good to have you here. All right, let's go back to our tutorial. So we learned how to iterate all the parameters in our entire model, which we can probably use for something in the future, maybe. I don't know. I'm a crab god. You are absolutely welcome. Thank you, Stephen Hart. I appreciate it. Thank you. Thank you. We'll do a heart icon back. Whoop, that's not a heart icon. This is... I can do that. I know how to do text. Okay. I know how to... Hey, I found a bug. Oh, I found a bug. I found a bug. There we go. That's what we do. All right. Good to have you here. Happy Wednesday, you guys. Okay, let's keep going. Let's keep going. This shows the fundamental structure of Pytorch model. There's an init dunder method that defines the layers and other components of a model, including the activation. All right, we got the activation. Thank you for the hearts, you guys. And a forward method where the computation gets done on the forward pass. This means that you're pushing data through the model. That means you're going to ask the answer. It's basically, you're going to ask the model a question. Thank you for the hearts, you guys. Appreciate it. Note that we can print the model and any of its submodules to learn about its structure. That's what we just figured out just now. Linear layers. The most basic type of neural network is a linear or a fully connected layer, the dense layer. This is a layer where every input influences every output of the layer to a degree specified by the layer's weights. The layer's weights are just numbers. There you go. There you go. Right here. These are weights. Right there, you guys. Those are weights. Right there. Number 7. Right here. These right here. Those are the weights. Right there. These are called WEIGHTS. Weights / biases, right? Weight / bias. Or the parameters. Right? They're the same thing. Or the coefficients. Thank you, Kenneth. Hey, Kenneth, thank you for subscribing. Welcome on in. Happy Wednesday. You joined the right channel for software engineering. We're becoming Pytorch experts, you guys. The coefficients, the parameters, the weights, or you could just say numbers or floats, right? The floats right there. I fixed the bug. You fixed the bug. Thank you for subscribing. Good to have you here. Happy Wednesday, you guys. Look, all these same, or also, wait, the matrices, right? Or vectors, right? What other words? Tensor. How many words do we need to say numbers for, right? How many times do we, look at all these words. They all mean the same thing, you guys. They all mean the same thing. They're all numbers. It's crazy. It's crazy. Making things complicated for people. Why do you do that? Why do you do that? All right. That's just one of my pet peeves with math. They come up with every single possible word for a word of a number. If a model has m inputs, numbers, what do they mean? Right? Fizzy, exactly. What do they mean? You found a gem actually here. Thank you, buddy. Hey, I found a bug. I appreciate it. That's great feedback. My gratitudes. If a model has m inputs and n outputs, the weights will be the m and n matrices. For example, and new programming languages keep adding new names and switching things around, like, for example, slice versus array. Yeah, exactly. The slice is, a subsection of an array or a matrix. Like, come on, you guys, a vector. What are all the things you need? Just a bunch of numbers, a bag of numbers. It's a bag of numbers. Never mind, you fixed the bug. What's going on? Wait. Oh, thank you for following over on the purple platform. Hey, how's it going over there? Hello. Your screens look different. So you see a big screen over here, right? The desktop, and you see the subtitles down here. Looks different. These are different numbers. There are 9 and there's a 9. That's true. There's different numbers. Did you guys know that you could have a different number? It's like 9 or 9. It's a symbol of the same meaning. It's a symbol of the same meaning, 9 and 9. I think there's a difference, but I don't know it. There is a difference. It's subtle. I just think it's unfair, though, to have so many different versions of it. A tensor means any of these things. It's a simple number, because a tensor can be a scalar. Oh, a scalar. Hey, there you go. Here's another thing right there, a scalar. And you know about scalars, you guys. Essentially, it just means a single number. That's what that means. A single number. Now I want to make a casual programming language where our arrays are called bogus numbers, and variables are called something, and classes are called a thingy. Yeah, make a thingy. No, it's not the same thing. 9 and 9 is not 9 and 9. Oh, we got some logic here. What's bias and how to determine it? All right, also, bias, right? Which we add up here. Bias is a vector, right? Bias is a vector, which means it's a one-dimensional array. So a 1D array. A tensor is any number. That's what a tensor is, right? Matrices is a 2D array. Coefficients is usually it's meant as a number that's going to be multiplied. So it's a number that is a constant that's going to be multiplied, but it's also weights, parameters, and bias. They're also coefficients. Parameters are weights and biases. So these two things are closer tied. Float is a certain type of number that has a fraction, right? Fraction, right? And you've also got integer. You get the integer, which means a non-fractional number. There you go. Non-fractional number. There you go. Oop. So that's what we got here in terms of numbers, you guys. Look at all these fun words we got going on here. Look at all these fun words. It's just usually like 2D, for example, or 2x, or 5x, right? So the coefficient is the 3 and the 5 in an equation. That's what that is. That's what that is, you guys. All right, we got 19 minutes. We're good to go. Look at all those words for numbers. Isn't that crazy? Off-topic question. I have a Raspberry Pi 5 at home that has been running Docker servers or services for home servers. All right. 1 terabyte SSD, 8 gig RAM. Should I transition to PMOS? I don't know what that is. I think if your Raspberry Pi is working fine, you're good to go. Why transition? Why remove? Silicon's expensive now with AI taking over all the memory needs for building more AI systems. Anasazi, you got a model working great, shows you can build an AI from scratch, scores 9.2 overall, and yes, maybe grading my own homework. Yeah, I know you are grading your own homework there. It's still compared to leading model. That counts. That counts. You did it. You did it. That counts. Good job. Good job, Anasazi. I want to do what you did. We're going to do it without AI, though. We're going to write it by hand. Look at link share. 9 is not 9, you guys. 9 is not 9. All right, link share, link share. Okay. Numbers, tensors, when making AI. Exactly, right? Which one's which? You don't know. You don't know. It's too late. Because numbers and tensors, they can be different things. They can be. They can be different things. I know, right? Let's get this scary. This is scary. It makes me crazy. Okay, let's go back to our tutorial here, you guys. Okay, so what are we learning next? Linear layers, fully connected layers. A linear layer is going to be a dense layer. Essentially, it means that it's going to be a 3x2 matrix, and then you can have a 1x3 matrix. Okay, these two are. Wait. Linear versus. What's the difference between these two things? I want to see what the difference is between these two things. I want to find that out. Okay, 1 second. We're going to dig in this. We're going to dig into this, you guys. We're going to dig in. Okay. So that's parameters. Let's close that. What are we going to call this? I want to call this something. Linear layers. Hey, this is my favorite song, you guys. I really do like this song. This is one of my favorites. This is my jam. Okay. Linear. Okay. Import torch. X equals torch.nn linear. We'll go 3x3. And then we're going to Y equals torch.rand 3x3. Let's print these out. Print X. Print Y. All right. Are these the same thing or are they different? Where did you get this presumably royalty-free music? This is in YouTube Studio. YouTube Studio. You just click, I do instrumental only, and you click price 0. And that gives you a giant list of, actually no, it's a very small list. It creates a very small list of music that you can play. This is my favorite song on the list though. All right, Python linear. Are they the same? No, they are not. They are not the same. Parameters. Execute. Are these only open on YouTube? I think they're free everywhere. They're free everywhere, so you can download them. You can download them. There's a download button. Yeah, so see here, there is a download button right here. So you see each of these has a download button. You just click on that download button, download, and it will give you the full song. Download it and you're good to go. You're good to go. Proxmox is a virtualization hypervisor. It allows live spawning and managing virtual machines. Proxmox, you want to change because it offers more functionality. What are you using instead of Proxmox? I use C groups. It's not a virtualization thing though. I use containers. I don't use virtualizers because you don't need to. Docker containers, right? They're Docker containers, right? C groups, right? C groups version 2. I like C groups version 2. Use Proxmox on your servers, your 3 servers in your server rack. Oh, okay. Yeah, it's better isolation because it's complete full isolation for the most part, right? All right, you guys. All right. La 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 la. 1 second. Think we're good to go. Okay, let's keep going. So these two are not the same, although they give you similar. Let's see here. Print this out now. Parameters. Oh, so let's do R in R for R in. There we go. Parameters. It's going to include automatically the bias. Oh, okay. So you're going to want to use this inside your model. Always. Always inside your model. Oh, there we go. Now we're figuring it out. Hey, how's it going there? Ilya, thank you for subscribing. Good to have you here. Happy Wednesday. You're joining the right channel for software engineering. Also, we got Salma. Solemn, thank you, Solemn, for subscribing as well. Good to have you here. Welcome on in. You guys, we are learning things out. All right, so always use the linear for inside your model. Inside your model, right here. Inside your model. Use this, because it's going to include bias as well. For outside your model, right there. So, or you might use this inside somewhere. I don't know where. I know where you use it. Oh, wait. You could probably, maybe, use it as a filter. Use it as a filter. Indent your model. Oh, yeah, no. Yeah, I know. You can see how I'm typing there, right? You're the best. You're my favorite live. Oh, Kate. Thank you, Kate. Appreciate it. That's really great feedback. Great to have you here. It was fantastic. Oh, nice. Didn't know Raspberry's RAM can handle it or not. But thanks for the answer. Hey, yeah, you got it. Absolutely. You got it. On top of that, you run a 9-node Kates with 3 control plane nodes and 5 worker nodes and a high RAM game server. What are you doing over there? F4N, what are you doing? Why do you need that much compute? And why are you using Kubernetes for something like a personal project? For a personal project, that's crazy. I think I'm 80% done migrating from my server to Cloudflare workers, Vercel, and Netlify. Nice. Nice. That's good progress. That's good progress. Thank you for the reactions, you guys. Good to have you here. I know, right? But I don't even have that. I don't even, I mean, at my company, we have a lot. We've got giant Kubernetes clusters at my company. We've got, what is it? 5 to 50. We got like maybe 20 Kubernetes clusters globally spread out across the planet. Globally spread out, like a lot of clusters, you guys. Maybe more, no more than that. We've got like 30, I think. I don't know why I said. Yeah, it doesn't matter. We got a lot of clusters. I have an enterprise grade network in your home. Oh, nice. You run your own servers for your family because you have trust issues. What are you doing over there? You got your own DNS set up over there. You got your own DNS server. You got your own DHCP. What do you got going on? As a beginner, hey, how's it going there, Raj Rear? Welcome on in. Do you have a common flow when trying to make a model from scratch? Yes. Yes, we do. You want to do this right here. Here's a common flow. Linear. No, not linear. Parameters. I think we're going parameters. Yeah. So this right here. So you're going to create a new subclass of Torch module, and you're going to initialize it, and you're going to start creating layers. And I like to do a sequence like this, so it makes my forward function really small. That's it right there. Hey, Chad, good to see you. Hello, friend. Welcome on in. Good to have you back, Chad. All right, you guys, where do we at? We got 9 minutes left. Okay, let's continue onward. These two things are different. The weights and biases and just weights. Oh, this is great. This is great. None of your business. Thank you for clicking the hello button. Good to have you here. Yes, actually, you have your own DNS and DHCP, multiple VLANs. You got some VLANs in there yet? Running Linux. You got some Linux. Are you using IP tables? Also, firewall isolated IoT devices. Smart. Smart. Yeah, don't let them call to the public internet. Your DNS is full resolve from root hints. Nice. Very nice. Hey, you've got everything set up over there. What? What do you mean? What do you mean what? Oh, are you a millionaire? Oh, hey, Chad. Asking some personal questions, are we? Is that what you're doing? Asking some personal questions? Well, oops. Let's see here. Let's go to my profile. All right. Well, you can at least see where we're at here. So those of you who are new to the channel, welcome on in. My name is Stephen Blum, CTO at PubNub. I do got to jump for a meeting here pretty soon. We raised 134 million, Series E, 1 billion devices on my network. We have 68 patent claims that have been granted. They're real patent claims. You can see them. They're down at the bottom of the screen. Hey, programmer next door, welcome on in. Good to have you here. Thank you for clicking the hello button. And here are my patents. They're down here somewhere. They're down here somewhere. Here you go. Recommendations. Here we go. Patents right there. You can see all the patents and all the claims in every single patent right here. There you go. Right there. And this patent alone has 20 claims, you guys, all granted. Efron's setup is insane. It sure is. It's a really good setup. Great setup, you guys. That's powerful sounding. It is. Cheers, buddy. Thank you. Toronto, Canada. Programmer next door. Oh, you're in Canada? Hey, very nice. Oh, you're our neighbor. Welcome on in, buddy. Good to have you here. All right. So we just learned some pretty interesting things. We are getting good at this Pytorch thing, aren't we? We're getting good. We are getting really good. Okay. We can run a forward pass on a linear layer. Oh, you can? Okay, that should be we have to do that. We have to do that. I know it sounds silly, but we have to do it. John Sphinx. How's it going there? Sphinx, right? No, Spheonix. Hello. Do you think I should learn LangChain as I'm learning about AI engineering, or should I skip it? LangChain is a good way to understand sort of a workflow when interacting with large language models, because you need to do some tool calling, function use, then you need to process that output, and then you need to continue on from there, right? So LangChain helps you do that. LangChain is great. I think it's a good idea. Yeah, I too have Pi with DNS for your network traffic. Nice. Yeah, I'd show you guys. I do have some equipment myself. It's over there. You can't see it. It's over there, though. It's on the shelf. It's pretty good. It's a bunch of ARM processors dealing with my network. Thank you. That's great. When working with Smooth, nice. It's a lot of work when it breaks. It is. That's a good point. There's upkeep. You got it. There's upkeep. You think getting heat from investors and managers is intense? Wait for your wife, Argo. Aggro? Yep. Try wife aggro. Exactly. Maximum stress. All right, let's try this. This might be the last thing that we get going here, and then we got to head out. Great question, John. Okay. I've heard LangChain and the other suite of tools is awesome. It can get pretty heavy, though. It can get heavy. You got it. Okay, you guys, here's the last one. We're going to do one more thing here, and then we're going to head out. We're going to look at using our linear layer as a forward pass. It has a built-in forward method. Linear. So I should be able to say print x dot forward. That should give me some data. It sure does. There's a forward pass right there. Thank you for the hearts, you guys. Appreciate it. So what we can do is, I think we can put y through it. We can put y through it because it's the right shape. We can. So let's go print x, y, like that right there. We should get some answers. We should get 3x3 output. A 3x3 output. Thank you for the answers. Thank you for the hearts, you guys. Appreciate it. I see where you're doing. I see the floaty heart icons right there. I see what you're doing right there. I see it. Thank you. All right. This should work, you guys. This should work right here. Last thing we do. Yeah, there it is right there. Forward pass. Boom. In a linear layer. Did you know you could do that? I didn't know that they did that. I didn't. On the music front, you have heard of Stream Beats by Harris Heller. I have not heard of this. Very interesting. But it's so good to have you guys here. Had a lot of fun today. We learned a lot. I'm surprised. Every time we learn something new here on stream. So where are we going to start tomorrow? Okay. So if the matrix multiplication X linear layers and the bias, you'll find that you get output vector Y. On the other important feature note, when you check the weights of our layers, it reported as if it's parameters, which is a subclass of tensor. Everything stacks on itself. That's crazy. We're learning the internals. So we got tensor, parameter, and module, and layers. That's crazy. It's great. It's great. Linear layers are used widely in deep learning modules. One of the most common places you'll see them is in classifier models, which will usually have one or more linear layers, where the last layer saves in outputs. The n is the number of classes in the classifier that it addresses. That's what we said. All right, tomorrow you guys will start on convolutions, and that will be planned for tomorrow. Thank you so much for joining. Had a lot of fun today. We'll be back tomorrow, you guys. Could you please comment the progress on GitHub of the live stream? Sure. Absolutely. I think we get status. Do we have any? Not a get. Okay. Hey, none of your business. Thank you for subscribing. Thank you for subscribing. Good to have you here. You're on the Discord. All right. So I'll put this on the Discord, you guys. I do have to head out. Also, if any of you have any questions about the setup as part, need your message Efron. Or yes, message Eforin. Message Eforin. Hey, Kate. Thank you for the gift. Thank you for the 200 jewels. Yeah, that's fantastic. Sent Sunshine for 200 jewels. Kate, thank you so much. That was great. Appreciate it. My gratitudes to you, bro. Pytorch or TensorFlow. Pytorch. I like TensorFlow with Keras is easier, though. Let's just say TensorFlow with Keras is easier. Join the Discord. All right. I'm in too many channels. I know, right? So many Discord channels, you guys. All right, you guys got to head out. See you tomorrow. Bye, everybody.